So let's declare it's a void function. We call it delay micro, and it takes one argument, which is a type int. And in this function, what we're going to do is we're going to use a nested for loop to create a false delay. And a nested for loop is built like this: int with two local variables, int I and j. And what we're going to do is for I equals 0, and I is less than n, and remember n is the name of the argument that the function accepts, I++, and then inside I we have another for loop. Inside this first for loop we have j equals 0, j less than 3, j++, and then this does nothing. This is just to waste time basically. So do not worry about where this number came from. There is a calculation for it based on the frequency of our microcontroller, which is 16 megahertz. I wouldn't go into the details of how we derive this number because this is not the right way of performing delays. We would use the right way later, so do not worry about this number. So we'll need two delay functions, as we said. While we are here, how about we create the other delay function? This one is going to give us delay in millisecond units. So I'm going to declare as void delay milli, and it also takes one argument, int n. The same way, we're using a nested for loop, I and then j, and we have for I equals 0, then I less than n, then I++. Bring the semicolon here, I++, and then we have the inner loop, which is j equals 0. Over here, j less than 3180. Do not worry about this number as well. And j++, and it does nothing. So these are our delay functions. They are false delays. Yes, so let's go back here. Now we have our delay. So in order to enable it, we delay here. The reason why we have this is because we've not added the function prototype up there. How about we add a prototype? I really do not like these red lines. So to stop it, all you have to do is add a function prototype here, like this, with a semicolon. And we can do the same for this one to stop the red lines. Could be with a semicolon. You see the line disappeared. Okay, there's one more function. Let's do it for this, so that we don't get a red line when we use it. So we paste here, semicolon, disappeared. Okay, so now we have almost all of our functions. There's just one more function left. We'll write it when we need it. So we have delay micro 0 here. This value 0, you should leave it. Depending on your microcontroller, you might need to tweak this value to 1 or 0 if the code is not running appropriately, but currently let's leave 0 for it. Yeah, if you check the data sheet of our LCD, or the data sheet of your LCD, which I presume the market has the same type of LCD drivers, you'd realize that the commands have different amount of delays, and specifically commands 0, 1, 2, and 3 have different delay amount compared to the rest of the command. So what we're going to do is create a condition here to give two delays based on the command that we are given to the LCD. We're just going to use an if statement here. I'm going to say if command is less than 4, which means if it's command 1, 2, 3, delay, give us a delay of 2 milliseconds. Delay milli 2. I wouldn't spell this well. Else, one else here. Delay micro, and this is based on the data sheet, which I do not want to bore you with. You can open it and check out, add the data sheets to the additional files with this particular video. Some data sheets come with 40 and 2 milliseconds, so based on your microcontroller you might need to not based on your microcontroller, based on your LCD, you might need to tweak this to 40 to delay 40 microseconds, but it should be well. So basically this is our LCD command function. So now that we have the function, we can come back here to use the LCD command function to initialize our LCD. So what we want to do, the first thing we want to do, as we spoke about, is to tell the microcontroller, or to tell the internal registers of the LCD what type of LCD we are using and the mode we want to operate it in. And this entire information is encapsulated in the code 0x38. And basically what this means is that we want to operate in 8-bit. Remember, we can send information in 4-bit as well as 8-bit. So we're telling it we want to operate in 8-bit, and our particular LCD has two-line display, and it has font of 5x7. So this what this information means. For more commands, you can check the data sheets. They have so many commands out there that you can check later. We still have this here. So we still have this here because we did not add the prototype of this function up there. So we copy, bring it up here, paste, Control V, and then semicolon. It should disappear. It's disappeared now. So we've added the first command. We're telling it, you know what, we want to transfer data in 8-bit, and our LCD displays in 2 lines and has a 5x7 font size. So that's good. The next command is to tell the LCD internal register to increment the cursor for us automatically, and the code or the command for this is 0x06. So all we have to do is LCD, our brand new function, put it to use, LCD 0x06, and let me put a comment here for you as well, increment automatically. Finally, the last 2 commands will be to turn on the display and then clear the display. To turn on the display, LCD command is 0x0f, like this, and to clear the display is 0x01. LCD command 0x01. So let's put this command here. Let's put this comment here. Just call it turn on display. Then we'll put another comment here. Clear display. So yeah, we've covered quite a lot here. We have to write one more function, which is the LCD data. The data function. This is the one that would allow us to send data. Then after that, we just start typing our data out. So we'll take a look at that in the next lesson.